Alright, so this is going to be a quick video over some of the review since I won't be in class today. I'm going to talk about how I got some of these answers for graphing and so on. So remember this key that I'm bringing up here, what I'm moving around. This can be found on my website under today's announcement, yesterday's, and Monday's, since we had some delays and whatnot. So double check there for all of the answers. Okay, now graphing quadratics. Numbers 1 and 2 are in standard form. Okay, and I have it written in red here. Okay, so if you look right here, standard form. To find the x of my vertex in standard form, I use this little formula, negative b over 2a. So I went and labeled my numbers a, b, and c. So now I have negative b, which is negative 4, two negatives make a positive, so I'd have 4 over 2 times a. Well, a is 1. So 4 over 2 simplifies to 2. That's the x of my vertex right here, and the line of symmetry, x equals 2. Now to find the y of my vertex, I went and I took 2 and I plugged it into the original equation here. And that's what I did here. 2 squared is 4. Minus 4 times 2 is 8, plus 3. Add all those together, we get negative 1. So 2, negative 1 is my vertex. So I went and plotted 2, negative 1 here. I labeled it with a V for vertex. I drew my line of symmetry that goes through the middle of my parabola. So it helps remind me that it's cutting my parabola in half. Now, in standard form, we know this was in standard form because there's no parentheses and our highest exponent went first. Okay, our exponent's going descending order. The y-intercept is 3. Okay, the y-intercept is 3. So I went into my y-axis at 3, plotted a point. I'm 2 units from my line of symmetry on the left, so I got to go 2 units to the right. I drew my parabola. My parabola opens up. Since it opens up, my vertex is a minimum point, and A is 1, so it's neither. So there is standard form. Number 2, you'd use the same process to answer number 2. Numbers 3 and 4 are in vertex form. We can see that because the parenthesis is squared. Vertex form gives us our vertex, so we use the opposite of the number inside the parenthesis. That's the x of our vertex, so negative 2. The number behind the parenthesis is our y of our vertex, so 3. So I went to negative 2, 3, plotted a point. I labeled that with a V for my vertex and drew my line of symmetry, which was negative 2. Then I went and I had to find a number that was close to the x of our vertex, so negative 3 or negative 1. Now to find the y of that, we need to evaluate a point. So I took negative 1 and I plugged it into my original equation and I got 2.5. So I plugged that in and I plot it. Negative 1, 2.5 is here. My reflection point would be negative 3, 2.5, or vice versa for those. I also decided to plot another point, so I picked the number 0. I plugged 0 into my original equation, did those operations, and I got 1. So I plotted my point at 0, 1. If you look, your reflection point, you are 2 units on the right, so you'd have to go 2 units to the left, so it would be negative 4, 1, or vice versa. This opens down, so that means our vertex would be a maximum, and this is a wide graph because of the 1/2. That makes it wide. Now, how did we shift our vertex horizontally? If we start at 0, 0, where the little hand is, we went to the left, and we went up. So horizontal shift was left and up. That is the exact same process you'd do for number 4. Remember, at any time you can pause this video. Now, 5 and 6 are in intercept form. So it's called intercept form. We know this because it's 2 sets of intercepts, or 2 sets of parentheses. in its intercept form, so it gives us our x-intercepts. So to do that, we take the opposite of our parentheses. We are solving those. So it'd be 6 and 4. So I went and plotted those x-intercepts. It's where they cross the x-axis. Now, the number that is right in between there is 5. That would be the x of our vertex and our line of symmetry. Or what else we could do to find that x of a vertex is add your x-intercepts together. So 6 plus 4 and divide it by 2. We'd get 5. So now to find the y of the vertex, we plug 5 into the original equation. That's what I did here. Do those operations, we get 5. That would be the y of the vertex. So I plot that, connect those points. This opens down. So since it opens down, it's a maximum. And that 5 there makes it a very narrow graph. And you can see by the graph. That is exactly what you do for number 6. 7 and 8, 9 and 10 are just distributing FOIL. Okay, we need to multiply them out. We want y equals, and we want our quadratic in standard form, highest exponent going to the lowest. So, number 7, I just distributed the 8v to both numbers in the parentheses. Number 8, I distributed the 4r to both numbers in the second parenthesis. Then I distributed the 5. Okay, and from there I got 4r squared minus 15r minus 25. Then I had to distribute that 2, that number that was out in front of the parenthesis. So I'd get 8r squared minus 30r minus 50. Now, if you wanted, you could have distributed that 2 to one of those parentheses first and then distribute it. Remember, though, you only distribute the 2 to one of these parentheses, not both. Okay, so that's what you do for 9 and 10 also. 11 and 12 are factoring a GCF only. So find what they all have in common. 13 through 18 is just factoring. Remember, find two numbers that multiply to your last number but add up to the middle number. So on number 13, we had to find two numbers that multiplied to 20 but added to negative 12. Well, the two numbers we would have used was negative 10 and negative 2. When you combine those, they combine to negative 12. But then when you multiply them, they multiply to 20. That's what you do for all through 18. 19 through 22, you have to solve those by factoring. So your first thing would be to get all of your terms on one side of the equal sign. Also, you want to keep your squared term positive. So if it's positive, you leave that and whatever is with it by alone, and you move the other terms on the other side of the equal sign. So for 21, if you look, your squared term is negative. Move that and the 14 to the other side so that you make them positive. You would make the a squared positive. It's just easier to factor that way. So then we'd have to find two numbers that multiply to negative 14 but add to negative 5. So it's negative 7 and 2. So a minus 7 and a plus 2. But now you would have to solve these. Think about what number could you plug in for a to make this parenthesis equal 0. So 7. This one would be negative 2. If you need to, set them equal to 0 and solve them. Or you could also think the opposites. Now, 23 and 24 are just graphing absolute values. Absolute value graphs look like a V. Okay? Now, absolute value graphs are very similar to graphing quadratics in vertex form. Okay? So, the number inside the absolute value, the opposite of that would be the x of our vertex, so negative 2. The number behind the absolute value is the y of our vertex, 2. So I went and plotted that, negative 2, 2. I drew my line of symmetry, x equals negative 2. Now, with absolute values, we can use this number, the a in front of the absolute value, to be able to use it as a slope to plot our next points. We cannot do that with quadratics, though, because it's not a constant change like absolute values or linear functions. So this is negative 4. So that means My slope would be negative, so I'd have to go down, and I'm going to go down 4 to the right one and down 4 to the left one. If you want, you can do that again. It opens down. It is a maximum since our vertex is the highest point, and the 4 makes it a very narrow, skinny graph. So that is a quick overview of the review. You can use this review on the test. Okay, if you have questions, please send me an email, okay, or talk to me before the test tomorrow.